So let's now deal with vector subtraction. In some cases, you have to subtract one vector from another to find what you're looking for. In this case, you set sail straight across a 300-meter lake northwards. At the destination, however, your GPS unit tells you that you are actually 330 meters at 23 degrees west of north from your origin. How far did the wind push you? Again, let's draw it out first. So you intended on sailing straight north 300 meters. However, at your destination, so this is your origin, and here is your destination. At your destination, your GPS tells you you sailed actually 330 meters at an angle of 23 degrees. First of all, let's convert this 23 degrees into RCS. 23 degrees west of north is actually 113 degrees RCS. Now the question asks us, how far did the wind push you? Well, to truly calculate the distance, you have to take into account the sailing distance plus the wind distance, in red here, to give you your actual distance, here the 330 meters. So in words, actual equals sail plus wind. And we're looking to find wind. So to rearrange, wind equals actual minus sail. So when we do our vectors, we know we need to subtract our sail vector from our actual vector. Okay? So once again, because these two vectors are at an angle, we're going to break it down into components. Again, we're going to use a table to help us. So our first vector, when we set it up, should be our actual vector, because we're going to do actual minus the sail. So our actual vector is 330 meters at 113 degrees RCS. And our second vector is going to be our sail vector, which is 300 meters straight north. 300 meters. Straight north in terms of Cartesian coordinates, or RCS, is 90 degrees. And now the x components would merely be 330 times the cos of 113 for the first one, and for our second vector it will merely be 300 meters cos of 90. And our y components, similarly, now we're going to use the sine function instead of cos. 330 sine 113 and 300 sine of 90. Now, remember, again, we have to subtract now instead of add. Subtract. When we do our subtraction, 330 cos 113 minus 300 cos of 90, the answer that we get is negative 128.9 meters. And 330 sine of 113 minus 300 sine of 90, the answer there is small number, 3.77 meters. So these two numbers, negative 129 meters in the x direction and positive 3.8 meters in the y direction, are the components to the wind vector. So let's use Pythagoras to combine these two components back into one vector. Again, let us draw a small sketch. So our y component is 3.77 meters, and our x component is 128.9 meters, and we want to find the diagonal. So our actual wind vector is the square root of 3.77 meters squared plus 128.9 meters squared. So that becomes, well, there is no big change. It's still 128.9 meters. And to find this angle here, we're going to use the tan function again. The side of the triangle that is opposite to that angle is the 3.77 meters. So inverse tan of 3.77 meters divided by 128.9 meters. The angle here is very small, 1.7 degrees. So at the end of the day, we can say the wind pushed us 129 meters at 1.7 degrees north of west.